Hello, Professor. It's Mukhani Mukhannad Karim Muhammad from group P254. Today I'm giving a demonstration of the performance of the program using the simulator and describing how it's work and to check if everything is working fine. So I'm already done for everything. So we had here the Siemens S7 program to simulate the PLC, and we established a connection between it and between the Unity using the net to PLC as a virtual network. And here is our network address and service is running. As you see here, the simulator of the S7 is running from here. So let's first check our Unity project if all working fine. So we'll run our program. Okay, here right now we are on the manual mode. So in the manual mode we could control every pulp by using these buttons here. So here is like an push button. So if we push the button, it will establish an will make the bulb light top, and also every button here. You have an on-off switch for like bulb number 4, now bulb number 5, and we see here every bulb is working fine. Okay, let's run it on the PLC mode. So we'll control it using the PLC. So if we click the button number 1 and it's the start button, in our case here, it will make the bulbs run in sequences in a delay of 0.5 seconds, and we could stop this by pressing the button 2. So the button 2 here in our case is the stop button. So let's see how it's worked on the simulator. So right now we will press button 1 to make the program start. Let's minimize the net to PLC. So here, if we press the button 1, and as we see here, it turns into true for button 1, and if you press button 2, it make it true. So here I already ran the program again. Let's go to the main block to see our code here that's already programmed using the large language. So here is our gates, and here's our connections. So in a gate, there is a first gate, and here is a second gate and third gate. So right now there is button 1 is normally open. So when we press the button 1, it will close to establish a connection between the gate. So when if we click the button 2, it will stop the connection and open the circuit back again. And here we have a parallel connection, so it will always run until I click the button 2 to make the normally closed gate open. So it will stop the circuit from working and make it open circuit. Here we have timer, and this timer is giving a pulses. The delay here is 0.5 seconds, so it will give a square wave pulses like an on off. And here is also a second timer, and this two timers is turning off on and off for each others. Okay, and here we have the counter. The counter have a timer input and pulses input, and here's a pulses output, and the sum. And sum here is a maximum of 6 because we have 6 bulbs. So after counting to 6 pulses, it will reset itself back again and start counting again. So right now we see here it's 1, 2, 3, 4, 5, 6. It's counting every pulse. So how it's already making our pulps light in the sequence, we use here an if rule. The if rule is getting a counter sum from here and making an if rule. So if the sum is equal to 1, it will turn on pulp number 1, and when the sum equal to 2, turn on the pulp number 2 using the pulses, and here the sum number 3 turn on pulp number 3, and also for the rest of them is the same. And thank you, Professor, for your time.